Good morning once again. Let us start. Yesterday in the class we discussed about questions of exercise 8.1. Now today we are coming down. Today's topic is the midpoint theorem. That is very important theorem for class 9 as well as for class 10. You would have to apply this theorem in class 10 also. Midpoint theorem, page 148 of your NCERT book. Right? Take a look at that, page 148, the midpoint theorem. It says that theorem number 8.9. It is there on the board for you all. The midpoint theorem. What is midpoint theorem? The line segment joining the midpoints of two sides of a triangle. I have drawn the figure for you. This is a triangle ABC. DE is the line segment which is joining the midpoints of AB and AC. D and E both are midpoints of the sides AB and AC. And this line DE is the line joining midpoint. It says the line segment joining the midpoint of two sides of a triangle is parallel to the third side. This line DE is parallel to the third side. We will prove it. How? And is half of the third side. This DE is half of DC. It is not given to you in the statement of 8.9 in your textbook, but we shall apply it, we shall prove it. Alright, in the proof it is given to you in the last. We will do it over here. What do you mean by that? So this is a triangle ABC. In this triangle ABC, D is the midpoint of AB, E is the midpoint of AC, and we have to show that this DE is parallel to BC. So what is given to us? We are given triangle ABC in which D and E are the midpoints. D and E are the midpoints of AB and AC respectively. What we have to prove? We have to prove that first DE is parallel to BC and second DE is equals to half of BC. Alright students, this will be used in class 10th as well. So that is why the proof is very important, page number 148 of your textbook. Right, now construction will be required over here. What construction? Please observe. We are going to produce this DE. We are going to produce this DE such that this CF is parallel to DD. Alright, this CF is parallel to BD. What is the construction? Produce DE to F such that CF is parallel to AB. This CF is parallel to AB. Alright, now observe it. Very. Write down the things what are given to us. Proof. What is given to us? We are given that D and E are the midpoints. So we will write down that AD is equals to DB, AE equals to AC. Because D and E are the midpoints of AB and AC respectively of triangle ABC. Therefore, AD is equals to DB, AE is equals to EC. AD is equals to DB and AE is equals to EC. This is given to us, so we have mentioned nothing else, nothing new. Alright, now take a look at this triangle ADE and CEF. Now, in triangle ADE and triangle CEF, ADE and CEF, these two triangles we are talking about. Can you see AE equals to EC given to us? AE equals to EC given to us. right? Can you see this angle equal to this angle? Reason, vertically opposite angle, theorem number 6.1 of your textbook class 9. If two lines intersect each other, DF is a line, AC is a line. If two lines intersect each other, then the vertically opposite angles formed are equal. We had proved it, right? Angle AED is equals to angle CEF, vertically opposite angles, and is this angle equal to this angle? Angle DAE equals to angle FCE. Angle DAE is equals to angle FCE. Why? Reason, check. These two are parallel lines and this is a transversal. AC is a transversal. So angles on either side of a transversal between two parallel lines are equal. Alternate interior angle, page number 100 of your textbook NCERT book, theorem number 6.2, right? So alternate interior angles. So therefore triangle ADE is congruent to triangle CEF by what congruency? ASE. Angle, side angle, two angles are equal and the side included between them is equal. ASE. So what? If these two triangles are congruent to each other, will this DE be equals to EF? Yes sir. So DE is equals to EF, CPCT. Right? Then is this AD equals to CF? Yes sir. AD is equals to CF. Reason, CPCT. CPCT. Now what did I get? What did I get? Observe. Take a look at quadrilateral BCFD. This quadrilateral. Is this AD equals to CF? Yes sir. But AD was equals to DB. AD was also equals to DB. So will this DB be also equals to CF? Definitely sir. AD is equals to DB. AD is equals to CF. So will CF and DB be equal? Ram is Shyam's brother. Shyam is Mohan's brother. So will Mohan and Ram be brothers? Yes. Things equal to the same are equal to each other. So here AD is equals to DB given to us. AD equals to CF proved over here. So will DB be equal to CF? Now because AD is equals to DB given to us, and put it in the box so that you can see that, and AD is equals to CF proved above. Here we have proved. So therefore is DB equals to CF? DB equal to CF. DB is equals to CF. Now observe quadrilateral BCFD. In this quadrilateral, a pair of opposite side DB is equal and parallel to CF. So theorem 8.8 of the same chapter. 8.8 of the same chapter says if in a quadrilateral a pair of opposite side, a pair means one pair of opposite side is equal and parallel, then it is a parallelogram. So therefore in quadrilateral BCFD, in quadrilateral BCFD, DB is equal to CF and DB is parallel to CF. So therefore it is a parallelogram. This is a parallelogram, and if it is a parallelogram, will this DE be parallel to BC? Yes. So DE is parallel to BC and DF is equals to BC. DE is parallel to BC and DF, the total to BC. Right? So we had to prove DE parallel to BC. Did we get DE parallel to BC? Here it is. First part, prove DE is parallel to BC. A line segment joining the midpoint of two sides is parallel to the third side. The line segment DE joining the midpoints of AB and AC is parallel to the third side. Right? And he says, prove that it is also half of that. Now check. Sir, DE is half of BC. How? Check. Sir, we had proved these two triangles congruent in the beginning. Here it is. Students, I would like that all of you maintain discipline in your life class. And DE is also equals to EF. Why? Again CPCT. Here it is DE. We have already mentioned DE is equals to EF. And DE is equals to EF and DF is equal to BC. So observe carefully. Now DF is equals to BC. Here it is proved above. Now observe this DF. This DF is made of DE and EF. So DF is written and broken and DE plus EF is equals to BC. But is DE and EF equal? Because DE is equals to EF. Here it is. Proved above. So can we replace this EF by DE? So DE plus DE is equals to BC. DE plus DE, twice of DE is equals to BC. 2 is in multiplication, goes in division. So DE is equals to half of BC. This DE is half of BC. Very important theorem, very important topic for class 9th as well as for class 10th. Clear? And your entire exercise 8.2 is based on this theorem. It says that the line segment, which was the line segment DE, joining the midpoints of two sides, D and E were the points, joining midpoints of the two sides AB and AC, is parallel to the third side. This DE is parallel to the third side and this DE is half of the third side. Clear? So this is very, very important. And you have on the very same page, you have theorem number 8.10, that is converse of mid point theorem. Mid point theorem. Converse of mid point theorem. Converse of mid point. What does converse mean? Just opposite of that. What was he saying over here in mid point theorem? Line segment joining the midpoints of two sides. Then the line is parallel. In 8.10 he says a line drawn through the midpoint of one side parallel to another side bisects the third side. He says, we don't need to prove it, we just have to understand. He says in this converse that in a triangle, say triangle A, B, C, a line is drawn to the midpoint of one side, AD is equals to DB, and this DE is parallel to BC. In midpoint, we prove that D is parallel to BC. Here he is telling you that DE is parallel to BC. Then the third side is also bisected. Then this E is the midpoint of AC. Then this AE is equals to C. That is the converse of midpoint theorem. Right? So this is what we have to apply in the exercise. Entire exercise 8.2 is based on the same theorem. Nothing new. You have to understand, you have to fit it into your mind. What if a line is parallel to one side of a triangle? If a line is drawn to the midpoint of two sides, then the line is parallel to third side. Then that line is equals to half of the third side. Okay. Theorem proof is there in exam. You can be asked the proof as it was there. Now we come down to few questions of exercise 8.2, which we have to solve on the application of this theorem. Nothing new. If we understand this theorem, we can do it. If we do not understand this theorem, it becomes difficult. Let us see Question number 1, 2, 3, 4, all of them are on the same topic. Only observation. Right? 8.2 he says ABCD is a quadrilateral. PQRS are the midpoints of AB, BC, CD and DA respectively. Show that SR is parallel to AC and this. I am not removing this figure for your convenience. I am not removing this statement for your convenience. I am removing the proof. Please solve this proof in your notebooks. It will be very helpful to you. Alright. The figure of exercise 8.2 first question is given to us. It says that in the given figure PQRS are the midpoints. Exercise 8.2 first question. This is the figure for us. This is A, B, C, D. He says a quadrilateral given. Quadrilateral A, B, C, D in which P, Q, R and S are the midpoints of AB, BC, CD and DA respectively. P is the midpoint of AB. That means this AP is equals to PB. Q is the midpoint of BC. That means BQ is equals to CQ. R is the midpoint of CD. That means CR is equals to DR. And S is the midpoint of AD. So AS is equals to DS. This is given to us. What we have to do, 4 things we need to do. Students, you don't have to solve anything over here. You just have to apply the theorem. It is very easy. You just have to apply the theorem. What does he say? Prove that SR is parallel to AC and SR is half of AC first. SR is parallel to AC and SR is equals to half of AC. Second, he wants us to prove that PQRS is PQ is equals to SR. And third, he wants us to prove that PQRS is a parallelogram, I suppose. Yes. Check. Construction, we will be doing one construction way. Just check. Let us join what are things. He says SR is parallel to AC. Where is this SR? So this is SR. And this is AC. Where is AC? This is AC. Right? This SR is parallel to AC, he says, and he says SR is equals to half of AC. So just now the figure is there. The line segment joining the midpoints of two sides of a triangle. Check the triangle ABC. Is S the midpoint of AD? Is R the midpoint of CD? So is this line segment SR the line joining two midpoints? Then this SR is what to AC? Half of AC we have proved. Then this SR is what of AC? Half of AC. We don't have to solve entire thing again. You have to just write it down. You don't have to solve. Just write it down. Construction we will do it if required. Proof. In triangle ABC, S and R are the midpoints of AD and CD respectively. So therefore SR is parallel to AC and SR is equals to half of AC. Reason: by Mid Point Theorem. What was Mid Point Theorem? Mid Point Theorem was the line segment joining the midpoints of two sides. S and R were the midpoints of AD and CD is parallel to the third side and half of the third side. Equation number first. You don't have to solve it. Only thing is the statement. Now second thing says PQ equals to first part proved. So no, nothing proved. Only statement was to be written. Second, PQ equals to SR. Where is PQ? So this is PQ. So again check. Take a look at triangle ABC. Is this P and Q the midpoints of AB and DC? So will this PQ be parallel to AC? Will this PQ be half of AC? Again by what theorem? midpoint theorem. Only thing changes in triangle. Now in triangle ABC, P and Q are the midpoints. P and Q are the midpoints of AB and AC respectively. So therefore, PQ is parallel to AC and PQ is equals to half of AC. Equation number second. Reason by mid-point theorem. The line joining the midpoints of two sides of a triangle is parallel to the third side and half of the third side. So that means SR was half of AC, PQ was half of AC. So from equation first and second, is PQ equals to SR. SR is half of AC, PQ is also half of AC. Right hand side is equal. So will the left hand side be also equal? Second part true. Similarly, SR was parallel to AC, PQ was parallel to AC, and PQ is also parallel to SR. Write down the reason. Because PQ is parallel to AC and SR is also parallel to AC. The lines parallel to the same line are parallel to each other. Theorem number 6.6, page 101. Right? So PQ is equals to SR, PQ is parallel to SR, PQ is parallel to SR. To observe this quadrilateral. Please observe this quadrilateral. PQRS is a pair of opposite side equal and parallel. So therefore it is a parallelogram. Theorem number 8.8. Now in quadrilateral PQRS, PQ is equals to SR and PQ is parallel to SR. So therefore PQRS is a parallelogram. Reason theorem number 8.8 of your textbook. If a side of a triangle, if a side of a quadrilateral is equal and parallel, then it is a parallelogram. Clear? Nothing new. Application of the midpoint theorem, that is what you have to do. Question number 2, 3, 4, 5, 6, all of them are same. All of them are same. Let us do one more question. Question number 4. ABCD is a trapezium in which AB is parallel to DC and BD is a diagonal and E is the midpoint of a line drawn through parallel AB. Let us draw the figure. Why I have not done second and third? You can do these questions, but if you have a problem, you can discuss it again tomorrow, no problem. Alright, take a look at question number 4. ABCD is a trapezium in which AB is parallel to CD A, B, C, D is a trapezium. AB is parallel to CD. What is given? We are given trapezium A, B, C, D in which AB is parallel to CD. Then what we have to, what is given? BD is a diagonal and E is the midpoint of AD. BD is a diagonal and E is the midpoint of AD. E is the midpoint of AD. Right? And he wants us to prove a line is drawn parallel through E, parallel to AB, intersecting DC at F. A line is drawn parallel to AB to intersect BC at F. Right? Okay. Then this point is not given. I will make this point as clear. What we have to prove? We have one more thing is given, that this EF is parallel to AB. What we have to prove? We have to prove that is the midpoint of BC. F is the midpoint of BC. Now here we are not going to do any construction, not everything is constructed for us, just proof. Now this theorem, the previous question that we did was on midpoint theorem. Now this question is on converse of midpoint theorem. What was converse of midpoint theorem? Theorem 8.10, it says that if a line is drawn parallel to one side of a triangle through the midpoint of one side, then that line is parallel. It bisects the third side. So see over here, please check, because EF is parallel to AB and AB is parallel to CD. So therefore EF is also parallel to AB, parallel to CD. Number one, EF was parallel to AB given to us, and because it was a trapezium, AB was parallel to CD. So EF is parallel to AB, EF is parallel to CD. Then what is given? E is the midpoint and E is the midpoint. E is the midpoint. So therefore AE is equals to DE. AE is equals to DE. Right? Now observe. This question is again there in class 10th. In triangle ADB. Now in triangle ADB, E is the midpoint of DE, E is the midpoint of DE given to us, and EP is parallel to AB because EF is parallel to AB. So therefore EP is also parallel to AB. So why? Because we can see if complete line is parallel, the part of complete line will also be parallel. So check this triangle ADB. This E is the midpoint of AD. This EP is parallel to AB. So check theorem 8.10. It says a line drawn from the midpoint of one side parallel to another side bisects the third side. It is bisecting this third side. That means this P is the midpoint of DB. So by converse of midpoint theorem, which is that theorem 8.10, P is the midpoint of BD. So therefore DP is equals to PB. Equation number first. DP is equals to PB. Right? Now we take a look at another triangle. Will this EF be also parallel to CD? Yes, sir. So will this PF be parallel to CD? Now we are triangle now in triangle BCD. PF is parallel to CD. PF is parallel to CD. Write down the reason, because EF was parallel to CD. So therefore PF is also parallel to CD. Right? And DP is equals to PB. DP is equals to PB, proved above. And DP is equals to PB, proved above. Equation number first. Here it is. So therefore, take a look at this triangle. The line PF is passing through the midpoint of one side, parallel to another side, then it does what? Bisects the third side by the same reason. So, by converse of midpoint theorem, PF bisects the side BC of triangle BCD. So therefore CF is equals to BF, that is F is the midpoint of BC, hence 2. So can you see, your statements have to be set in your mind. If the statements are clear, no question is difficult. Every question is the same. Question number 2nd and 3rd, if you try it out at home, you'll find that they are similar. They are not new. Right? So please practice theorem, midpoint theorem in your notebook. Practice question number 1, question number 4, it is being solved. And 2nd and 3rd, also you can try it out. If not, you can also find it out in the video afterwards.